Example 1. Cash. When an adult smartphone owner is randomly selected with replacement, there is a 0.05 probability that this person is cashless, never carries cash, based on a U.S. bank survey of over 2,003 adult smartphone owners in the United States. We want to find the probability that among 10 randomly selected adults, exactly 2 of them are cashless. Now the first question is, does this procedure result in a binomial distribution? Well, first and foremost, we need to figure out that this procedure does satisfy the requirements for a binomial distribution, so we need to go for the 4 of those. Number 1, the number of trials, 10, is fixed, so we know that there's 10 trials among the 10. Number 2, the 10 trials are independent because the probability of any random adult smartphone owner being cashless is not affected by the results from the other randomly selected adults. Number 3, each of the 10 trials has 2 categories of outcomes. The selected person is either cashless or not. Number 4, for each randomly selected adult smartphone owner, there is a 0.05 probability that this person is cashless, and that probability remains the same for each of the 10 selected people. Part B. If this procedure does result in a binomial distribution, identify the values of n, x, p, and q. Well, having concluded that the given procedure does result in a binomial distribution, we now proceed to identify the values of n, x, p, and q. Number 1, with 10 randomly selected adults, we have n, which is equal to 10. Number 2, we want the probability of exactly 2 who are cashless, so therefore x is going to equal 2. 3, the probability of success getting someone who is cashless for one selection is 0.05, so therefore p is equal to 0.05. Now the probability of failure, not getting someone who is cashless, is equal to q. Now q is taking 1 and then subtracting the probability of success, which is 0.05, which gives us 0.95. So therefore q is equal to 0.95. Lastly, consistent notation. Again, it is very important to be sure that x and p both refer to the same concept of success. In this example, we use x to count the number of people who are cashless, so p must be the probability that the selected person is cashless. Therefore, x and p do use the same concept of success, being cashless.